Welcome to this special episode of Frequency Matters, the RF Microwave Update series. I'm Pat Hindle, and I'm talking with Dan Green, Senior Technical Director at Analog Devices. Welcome, Dan.
Thanks, Pat. Great to be here.
So today we're going to discuss chiplet technology and kind of how the landscape has changed and where the technology is heading. And you've been working on chiplets as a lead for a DARPA program for 10 years ago. And so you have a lot of experience in this area. So excited to hear what you have to say. So let's just start with, what are chiplets and how are they distinguished from conventional chips?
Yeah, thanks, Pat. It's a really good place to start. There's a lot of debate that has gone on in terms of what constitutes a chiplet. My own interpretation is that a chiplet is an IC that is intended to be used as a composable element in a multi-chip package, and where it uses a common parallel interface to enable chip-to-chip communications. And so while multi-chip modules have been with us for a long time, the key advance with the chiplet approach is designing with that multi-chip use case in mind and the establishment of standard energy efficient communication interfaces such as UCIe. And so for chiplets, an exciting time because we're evolving from research projects and proof of principles to product development and release.
And so why ADI and how is ADI engaged in chiplet revolution?
Yeah, so one of the key hurdles we identified from the outset in the community over a decade ago was that the establishment of chiplets really required to have a pool of chiplets that made sense to integrate. It doesn't do any good to design a chiplet interface if that chip has nothing to talk to. And so one of the strengths of ADI is that it has this huge portfolio of components, both in the catalog and in development. It also has the engineering discipline to arrange for these components to be combined flexibly into systems. For example, our Apollo MXAV are designed to leverage external power, clocking, and synchronizations. And we've also developed those pieces of the puzzle as part of our overall ecosystem approach. For example, we have our ion timing solution chips that are designed to provide timing synchronization flexibly across multiple chips, including Apollo. So our customers then can rapidly create phased array solutions where they can use our Apollo chips that are time aligned with our ion timing solution, or they can bring their own components to design the system as they see fit. So it's really this combination of critical mass of enabling components and a business model that enables our customers to choose how much integration and of what components is foundational to drive the overall chiplet ecosystem. Analog has really embraced this model now to build a portfolio of chiplets that supply a set of critical functions.
And so you mentioned an ecosystem. How does this work with parts from other suppliers?
This is a really important point. While ADI does bring a wealth of components to the table, we are engaged in the community and to enable a broad set of components to be interoperable, not just our own. To that end, the ADI team has been engaged with the UCI standards community. This interaction has really driven our common understanding of what is needed for different standards. Because when you look at how UCI handles data, most of the compute-to-compute or compute-to-memory application use a packetized format, which isn't compatible with data converters, which are important to us, which need to stream digitized, real-time, continuous events like radar pulses with deterministic timing. And to solve this, we're leading the standardization of the use of a UCIe raw mode under the JEDEC JESD204E working group. And to be clear, the idea is not to have one standard for everybody, but the minimum set of standards that is driven by a real understanding of what applications require different standards. So for example, that we just went through, our radar applications require deterministic latency, and that's at odds with data transmission requirements that is typically used for things like data center applications. And so we're involved towards two different standards in this case, but we're engaged with the community to make sure that we understand why we're doing those and then maximizing the reuse of those standards across a broad set of products from different players in those communities.
And so, what are some of the remaining technical challenges to implementing chiplet interfaces?
Well, the fundamental proof of principle has been established, there's still a number of technical and business challenges ahead. Two key hurdles include first getting the packaging approach correct for the chiplet design. Some of the advanced standards rely on dense interconnects, for instance, that require high density interposers in order to wire together adjacent chiplets, as well as advanced planning for how the dies fit around each other in the package and how those orient to the hub. ADI's initial approach is leveraging more conventional established packaging so that the chiplets can be realized as cost-effective standalone components in the near term, and they enable a little bit longer reach, up to 25 millimeters in package. So it has a little more flexibility to dock with a wider set of components initially. So we're supporting both of those. We're looking at both of those approaches. And I would say in any case, the other key technical hurdle is understanding the thermal budget, particularly for these dense CMOS circuits. And that requires consideration of heat sinking solution that take into account the full 3D geometry of these integrated multi-chip solutions.
And so, what applications are driving the embrace of chiplets?
Yeah, so the advance of chiplets is really being driven by the embrace of cutting edge CMOS capabilities. The additional capabilities that can be crammed into a chip, and the concurrent reduction of power that's enabled by CMOS at 5 nanometer nodes and below is undeniable compared to legacy CMOS nodes. However, there are challenges. There's been a lot in the press about how difficult it is to maintain access to these foundries. Less discussed, though, is the barrier to design in these nodes. It is very costly to tape out new products. Those can run into the hundreds of millions of dollars in these types of nodes. And there's only a few singular products that can justify that type of expense on their nodes, such as the SoCs that power our smartphones and get produced in the hundreds of millions of units. The role chiplets play is by aggregating demand for these components across many different systems. And they enable the business case to close for taping out these components in these costly processes. Interestingly, the bending of the cost curve is exactly why the DoD was looking at this a decade ago as they struggled with tape out costs. And I would say now the commercial markets are hitting the same type of considerations. It's just at a higher price point enabled by their much larger markets.
And so, finally, how do chiplets tie into ADI's overall strategy?
Yeah, it's a really exciting time to be at ADI. While ADI has always had and continues to grow our industry-leading portfolio of component functions, we're now extending and going from being a supplier that delivers components all the way to engaging more deeply as a trusted strategic partner, dreaming and co-creating the future. And what that means is that we're really investing in the technology stack to create more content with a system solution approach. These can be thought of as reference designs for systems with our components. And this approach allows us to really see the impact of features at the component level all the way up to the system performance. So we can optimize these offerings for our customers. Our chiplet strategy dovetails with this approach as we're able to understand the use cases for our chiplets all the way through integrated systems. We believe this feedback loop will accelerate our pace of innovation and enable our customers to get a better product faster so that they can accelerate their own products to market.
Well, thanks, Dan, for talking with me today about chiplet technology. I definitely learned a lot about what you're doing and how ADI is addressing this market. To our viewers, you can find more videos at videos.microwavejournal.com. Thanks for watching.